Hi everyone. Uh, Today I'll be taking you through our building of the Robot World, the Brownfield project that we've been doing together with my teammates, which are Lihlonolo, Cleo, Ernest, and Prime. Welcome to our presentation. Okay, so today I'll be taking you through an overview of the development, testing, and documentation process that we were involved. This project is particularly interesting because it's a brownfield project. A brownfield project is one where you start with an existing code base, code that has been worked on before. This means that instead of starting from scratch, you have to step into the shoes of the original developer. You need to understand what they were trying to achieve, how they were approaching the problem, and what design decisions they made along the way. This requires a deep dive into the existing code, figuring out the architecture, and sometimes unraveling the complex logic to see the bigger picture. One of the main challenges with a brownfield project is the need to balance respect for original design while also making necessary improvements. This can involve refactoring the code to make it cleaner and more efficient, updating updated libraries or frameworks, and even adding new features without disrupting the existing functionality. Um, in the case of Robot World, we had to carefully examine how the initial developer had set up the system to handle various robot actions, interactions, and data management. We then had to decide where to draw the line between preserving their work and implementing our own improvements. For instance, separating concerns between the data access layer and domain logic was a key architectural improvement that we made, ensuring that the code became more modular and easier to maintain. Understanding the original developer's intent isn't just about making the code work. It's about maintaining the integrity and vision of the project while you enhance its functionality. This is a crucial. It's crucial in a real-world software development where projects are often inherited and built upon by multiple developers. So, with that being said, I'll be talking about source code management. We used GitLab to manage and track changes in the source code files, enabling us to collaborate, take out accountability, and also the version control. And then I'll be also talking about the file organization. I'll be showing you guys how we structured our code and how we package different uh, functionalities in the code. Also, I'll be showing you the build automation where we automated the compilation, packaging, and testing of the software, ensuring consistent and reliable build processes. And then also, I'll be showing you guys a few uh, formats of the classes that we have in our code, how we maintained the code, the consistency of the code, and readability across the project. And then also, I'll be showing you guys the pipeline, the journey of the pipeline on our GitLab for when we did it for continuous integration. So um, now I'll go to our code. So first of all, I'll show you guys how we uh, retrieved and updated files to our repository. So to retrieve files, like maybe if someone updated something, we used the git pull, and it will tell me if there's anything. It will update me, and then it will tell me if my code is up to date. Okay, so now it says my code is already up to date, so there's nothing to pull. Everything that I have is everything that is on the repo. And then to update the repo, we usually checked the status first to see what files you have changed, and then you can select whatever file that you want to commit and push into the repo without disrupting other files. So in this case, it shows me that I've been working on these two files. So I'd like git add, and then just add the particular file that I want to push. And because I don't want to add anything right now, I'm not going to do that. And then the structure of our code. So we have different packages on our code. We have the API, the client, database, the main game, maze, protocols, server commands, the world, the test. So our main classes that are the main functionalities of the game is the client. So the client is the one that connects to the server in order to control what the robot does inside the world, the game itself. So we have the client, and then we have the interface for the client, and then we also have the robot world JSON client, and then we also have the database folder where we have the ORM inside. the database. So the ORM is the object relational mapping. This is the file that we use to convert data between incompatible type systems. It allows you to interact with relational database. It also handles the conversion of our data tables into classes and rows into objects, making it easy to manipulate the database records. It plays a crucial role in maintaining a separation of concerns and makes the database adaptable for the future changes that may come. So yeah, we have like the main domain object and the other domain objects inside the ORM, and then we have the database, the robot world database. This is where the database is controlled, and we also have the main game. In the main game, we have the robot commands. These commands are the commands that you will use to command the robot to do particular actions that you want it to do. And we also have a turtle for graphic user interface. We have protocols. This is where we format the response. Uh, we're using a JSON. We're using a JSON format to respond back to the client. So when the client commands whatever they command, the response that they will get from the server is in JSON format. And then we have the server. So the server, when you start the game, when you enter the world, you start by going to the server, and then you run the server. If you don't want to click on the terminal, of course, you run it from the class to run the server, and then the server will listen to the clients that want to come through, and multiple clients can go in concurrently. And this is our server class. So this is where the world is set, and then this is the code to start the server. It listens to the client, waits for the client to come in, and then concurrent clients can come in and join. And then this is where the server closes. And yeah, this is the JSON format that goes through to the terminal once the client commands anything. The response is in JSON format. So yeah, that's our server. Then we also have a client handler. When the client inputs the command, it goes to the client handler and checks what it has to do with that, and then it responds according to whatever it's meant to do. And then we have different kinds of world. We have the interfaces, and then we have a text world, we have a turtle world. And then we also have tests. It's very important to test your software. We have acceptance tests. These are so that we know that our project is functioning correctly. And then we also have unit tests to test different classes inside the project to see if that they are working as they are supposed to. So right now I'm going to go over to our GitLab and show you. Okay, so it went straight to the pipeline. So this is our pipeline. So this is our pipeline history. It shows that it's been a trial and error journey for this. So to get it to a point where it passes all the stages, we had to work and we had to make sure that the code is functional and every commit was tested. And then we also have our planning where we did all the planning. We have a wiki. So we have a wiki. Our wiki is divided into the different iterations that we had, and this is where we planned the different kinds of iterations according to what was needed for those particular iterations. So we have a wiki for iteration 1, we have documentation for iteration 1, and then iteration 2, 3, and so forth. So example, I'll just open any. So this is for iteration 2. So it has everything, documentation of how iteration 2 went and what we learned, challenges that we faced during that iteration and all that. So all these iterations have these different kinds of features, like where we explain what we were doing, how we did it, and how we achieved our goals. And then we also have issue board. And on the issue board, that's where we assign tasks to each other, and then we we knew like if a task was being done, was in progress, if it was done, or if it still needed to be done. So these are the issues, and then taking some time. Okay, so this is the issue board. So we had a backlog ready for development, in development, and ready for deployment, I think. Okay, in testing and ready for showcase. Okay, this is where we you check to see what still needs to be done, what is being done, and what is done. So we also have acceptance tests inside the okay. We have acceptance tests to test different scenarios, and we use behavior driven development to create these tests. Okay, I'll just open one to show. Okay, it's taking some time to load. I hope that it does open. But yeah, uh, okay, oh, it's really taking time. So we also have a README. The README just shows you an overview of our project and shows you how to run it and the different kinds of frameworks or IDEs that you should have to be able to run it. I'll show you the README. Okay, so these are the different kinds of scenarios and issues that we had in the past since starting the Brownfields Robot World project, and I just wanted to show you one of the acceptance test. So this is the acceptance test for launching the robot and the different kinds of scenarios when launching the robot. Okay, so let's go over to the README. Okay, while it's loading, we also have the contributor analytics that helped us see the contributions made by everyone, whether everyone has been contributing towards the project. And yeah, this is our README. So we have the overview, we have features, the features in our robot world. We have the project structure and installation, the IDEs that you should install, and what you should do when you want to run the project. You first have to clone it from our repo and then make sure that you have an any IDE that you can use to run it, and then make sure that you have the correct SDK configured, install the dependencies, and then when you start the game, you need to run the server first, and then run the client, and then after that you'll be in the game and you can command the robot to do whatever you want it to do. And we also have a make file, so when you're running the test, you can just make test. When you compile, you can just make compile, and so on. And yeah, so that's our project. Let me just show you the history of our commits and okay, yeah, I'll show you the repository graph that will show you the history of the commits that have been done since getting the project. Okay, so this is the history, and we all worked on the main. So we pushed to the main. There were no different branches. Everything went straight to the main. And when you push to the main, the pipeline would test that the commit was okay before. And if there's a red light, then we know that there's a problem with the building or whatever state that it's failing.
Let's delve into section B, where I will walk you through how the code aligns with the design specifications of the Brownfield Robot World project. So we'll cover several aspects, including code conformance with specification, data access mechanisms, design documentation compliance, testing strategy, and implementation. So code code conformance with specification. So I'll start by showing how the code I've written aligns with the initial project specification. For instance, this project For this project, the main responsibility of the robot vault database class is manage all interactions with our SQLite database, ensuring that the world's obstacles, pits, and mines are properly stored and retrieved. Every method in this class is designed to meet specific requirements laid out in the design phase. So methods of accessing data. Next, let's just take a close look at how the project accesses and manages data in the Robot Vault database class. I've established a connection to the database using ORM. Last iteration, we're using JDBC, and now we're using ORM. And then I've implemented methods to interact with the data. For example, we have start from the top. We have add world method that allows me to add a new world to the database by creating a world database object and saving it using the world database access interface. I have those as classes as well. If you see right there, or right here, I have world DO, which is the world database object, and then I have the interface for the world database access interface class. And similarly, we have methods like add obstacle, add pit, and add mine to insert respective objects into the database to retrieve data. I've implemented methods such as get worlds and get obstacles. These methods use SQL queries to fetch data and then structure it into data node objects using the object mapper. This approach ensures that the data is organized and easily accessible within application. So I will show you a quick demonstration of how to save the world into the database. We'll have to run our server class, and then you'll just say you just type in save with the world name of the database. You can name it anything. For now, I'll name my word as clear, and then clear is now saved. The world has been saved as clear. So we also have to jump into naming conventions. Another critical aspect of the project is the use of clear and purposeful naming conventions. Good naming practices make the code more understandable and maintainable, which is particularly important in a project like this. For instance, then let's go back to the robot vault database class. For instance, the robot vault database class immediately tells us that this class is responsible for database operations, which the robot vault project similarly methods just like the names like add world, add obstacles, and get information as well. Action orientated and descriptive, making it clear what each method does. Even the variables for the world database database access interface represents the data access interface. Connection refers to the database connection, and we have the object mapper, which is used for mapping the JSON file objects. These names help help anyone reading the code to quickly understand its purpose and functionality. So we then have to go back to then have to go back to our slide, which is adherence to design documentation. So during our project, I've also ensured that the project conforms to the design documentation. During this development, I followed the design closely, but there were instances where we had minor diversions or minor diversions were necessary. For example, while implementing the ORM for the database, I chose to optimize certain queries to improve performance. Those changes were documented, and I made sure to include them for reason for each diversion, and that's where we have it on our GitLab Azure boards. So for testing strategy, we had to ensure the robustness of the project. I've developed a comprehensive testing strategy. This is me and Ernest. The project includes unit tests, so we'll have to go back to our project. So the project include a unit test. Over here, we have a class for tests, and we have packages for acceptance tests and unit tests as well. So within the robot vault database class, to verify that we work as intended, for instance, we tested the add vault. We've tested the add vault method to ensure it correctly inserts data into the database. I've also stress tested for get world and test add pairs, get mines, and we also tested for the connection, and our unit tests do pass accordingly. And then we have the user instructions and installation. This is the design document compliance. In terms of user interaction, I've provided detailed instructions within the documentation, which is the README file over here. The README file over here. To help users utilize the project to its full potential. The user guide covers the README file covers everything from basic usage to advanced commands, ensuring that users can navigate the system with ease. For installation, we have how to set up our IntelliJ. So you have to clone for our GitHub repo. Then you will have to open the project in IntelliJ, or you can use your command line to open it there. You just have to cd to where the file is, and then you have to configure the project to the SDK, which is the version 17 that we use to complete our project. And then you have to install the dependencies or build a Grandel if you want to do that. But we used POM file, so you have to install the dependencies on the POM file, and then you have to like set up your database, ensure that you have SQL installed and configure it in your IntelliJ, and then you can run the database setup script, and then you can also run the server. So you will have to go to the server package and run the server there, and run the client as well, so it will both connect. So for that I've used on the server class here, we have client handler, which handles the connection between the server and the client. And then you locate the main class server and the other main class, which is clients. So for demonstration, we can run our server project. We run it first. Let's stop and rebuild it again because I built it. And then it's connected to the port 5000, and it's waiting for the clients to connect. And then we can run our clients, and then our client ran, and you can see over here that we have the socket connection as well with its local host. And then we can launch our robots to the server. Type in launch. You can name your robot how, and then you can choose a robot make, either sniper, standard, or a fighter. And then you can see that how has been launched onto the world, and you can check how many robots are there in the world. So one robots, and then see one robot launch how, which is in position 00. And you can our system, you can run multiple clients. So let's add another client to our server. Yeah, we have another class another client to our server. Let's put it over there. And then we can launch another robot into the world. Launch, choose a name dash, and then you choose a fighter. And then it was launched into the world. Here's the connection with its local host. And then we can check how many robots are in the world now. So 2 robots are in the world, which is HAL and DES. So you can give instructions to your robot as well. Forward 10, and then results okay, position 010, message done, direction it's facing north with its shields 5 and shots 5, status is normal, and position and shields as well, that's like the state. And then it shows the message that how has moved or does has moved 10 steps. So you also have the server response as well over here. So that's basically how, when you run our server and clients, what you're gonna see and how you can interact the with our system. So let's go back to the README file. So, but we also have Docker as well. So we've planned the process to minimize disruption. This project can easily deployed using Docker, which simplifies the setup and ensures that it runs smoothly across different environments. So you can run the image and the container as well. So let's go back to our VS Code. I'm sorry, not our VS Code. Let's go to our GitLab, and then we'll show the pipeline as well. Build pipeline. So here's our setup for the pipeline. So it goes through 4 stages, which is build. It passed that first stage. The second stage is test. It passed that one as well. The third stage is package. It passed that as well. And then the fourth stage is Docker, and it passed that as well. And then we can go back to our documentation. So like I just showed you that our documentation has is fully detailed for this project. It includes a description description of the project's purpose. At the top over here, we have the overview, which is the Brownfields Robot Wall project is a simulation based on environments where robots can explore, interact, and perform tasks within a text-based world. And this project is built to demonstrate the capabilities of a server client's application that supports multiple worlds, each with unique configuration. And the project includes features such as saving and restoring worlds, placing obstacles and mines, and handling various robot commands. And additionally, I've documented the test as well. I think I did went over the test, outlining the purposes and expected outcomes, which further supports the project's maintainability.
Good day. I hope you are doing well. My name is Lisa Ronolo, and I'll be walking you through database management system. As we all know that it's a system that is used to store, retrieve, and run queries on data. Data management problems. The first one is data redundancy, which is duplication of data across multiple locations. For example, when customer records are stored in separate systems. And the second one is data inconsistency, conflicting data due to various entry points. Consistency example would be different addresses for the same customer in different records. The third one is data security, which is unauthorized access or data breaches. The fourth one is scalability challenges, which is difficulty in managing growing data volumes. Solutions to data management problems. The first one is centralized data storage, which eliminates redundancy. This is single source of truth for customer data. The second one is data integrity constraints, which ensures consistency across data entries, which it enforces rules to prevent data anomalies. The third one is access controls, which manages security through user permissions. And the fourth one is scalability features, which supports data growth through indexing and partitioning. Features of commercial database management system. The first one is transaction management, which ensures data integrity and consistency. The second one is concurrency control, which manages simultaneous data access. The third one is backup and recovery, which protects data from loss. And the fourth one is security features, which includes your encryption, authentication, and authorization. The purposes of commonly implemented features are indexing, which speeds up data retrieval by creating pointers to data. The second one is query optimization, which enhances performance of SQL queries. The third one is backup, which ensures that recovery. It ensures recovery in case of failure. Characteristics of database management system types. We have relational database management system, which is structured tables with SQL queries. We have your NoSQL database management, which is flexible schema, scalable, suitable for unstructured data. And we have object-oriented database management, which stores data as objects and supports complex data types. And the fourth one, we have hierarchical database management, which is data organized in a tree-like structure. Example and use cases of database management types. Relational is your MySQL, which is transactional systems. NoSQL is your MongoDB, which is big data applications. Object-oriented is your complex data structure, and hierarchical is your IBM information management system. Database management system end user tools, features and limitations. Firstly, its features is query builders, dashboards, reporting tools, and data visualization. The limitations is usability issues, limited customization options, performance overhead. Applications of database management end user tools. Query builders are used for creating and executing SQL queries without programming. Reporting tools is for generating periodic reports and visualize data. And data visualization tools is to create charts, graphs, and dashboard for insights. Your reporting tools can be generating monthly sales reports, and your visualization tools can be for creating interactive dashboards for sales data. Database access requirements. The first one is authentication, ensuring that users are who they claim to be. The second one is authorization, granting appropriate access levels to users. The third one is connectivity, which is reliable access from various locations. And the fourth one is security, protecting data from unauthorized access and breaches. Database access objectives and performance factors. Objectives are efficient data retrieval, low latency, and high availability. And our performance factors are indexing, query optimization, server configuration, and load balancing. Database design for programs. Design considerations, which is with data types, relationships, and normalization. Data needs is storing user data and transactions history, and design is normalized tables to avoid redundancy and ensure data integrity. Key relationships in database design. Primary keys uniquely identify records in a table. Foreign keys, they establish relationship between tables. Relationships is one-to-one, one-to-many, and many-to-many. Examples: one-to-many is a customer can place multiple orders. Many-to-many, products and orders with multiple product entries per order. Maintaining primary and foreign key consistency. Importance is showing data integrity and referential integrity. Primary key is unique identifier for each record, and foreign key is it references primary keys in related tables. Thank you.
Good day. My name is Ernest, and I am going to demonstrate our SQL implementation and database management in our application. So we decided to write all our queries in this interface. So this interface has all the queries for creating tables, for inserting data inside of the table, and for getting data from the table. So starting here, so this right here creates a table named world. And each and every single time you call this method right here, it will execute this query. Same as for this one and for this query. So this one will create the pets, this one the obstacles, the top one will create the world table, and the other one will create the my table. So all of these are creating tables, all of these methods, and all of these methods. So we went with this approach to clean up our code so that we don't call each and every single query every time we want to create a table. We just call a method. And then if we go down here, we have our insert methods. If we want to save a world, pet, a mind, then we're going to run all of these queries. So this actually like inserts data into the table. So it creates a new row in our database. So it will use all of these values that we will get from um, the other components of the database. And that is where we use the preservation of integrity, which is the world, which is in here. We use this approach to preserve integrity in our database. So let's go to our API so that I can demonstrate how we can communicate data between the front end and the back end. So for doing that, we first going to start our server, and then we're going to run our API, and then yeah, it shows that our server is connected, our API server is connected, and our server is also up and running and currently is connected to this port, which is the API. So if we send a request for the current world, we're supposed to get a result from the API server. It's taking a bit of time, but we can wait. There we go. So when we go back to the API server, it actually prints out that it receives a get request um, at this page, at the world page. And if you go back, you'll see that we received data. So we use this implementation to communicate between our back end and our front end. And for sharing of data, we using methods to communicate, to share data throughout the whole application. We use these methods like this. If you want to add anywhere in our application, we use this method. Obviously, we need to initialize our constructor. We need to initialize this object using the constructor. And all of these methods will be used when we initialize our object, our database object, and it will get data from the database, and we'll be able to use it anywhere in our application. So yes, this is our code base for database. Now let's get into the database test, and the logic behind each and every single test. So before each test, we clear the tables in the test database, and then we create a new object, a database object. So the first test that we're going to focus on is the connectivity test, the test we test for connection. So whenever we initialize a new object, when we create a new database object, the connection automatically opens. So the only thing that we need to do is to get the connection data and the connection object by using this get method. And once we do that, then we'll be able to check if the connection is still open or not. And that is what we use this method for. So obviously this will be false because it checks if it is closed. Like I said, when we initialize, which this method will run each and every for each test. So when we initialize, the connection automatically opens. And then when we close it, we supposed to get a different result. So this is how we were able to test for connection, for database connection. So let's run the test. So we good. We get good. Our tests are good. And the next test actually is test for if we were able to add a world in our database, if we were able to save a world in our database. So we have our data that we're going to use to add a world in our database, and this is what we use this for. So what happens here is that when we call this add method, that this add world method, it checks if the world that we are trying to save is world inside of our database. And if it is, then it will return false. If it isn't, then it will continue, then return true. So let's go back there. So this is what this method does. It creates a table since there's nothing, because each and every single time we create a table, all the tables in our database. So this method will return true. And when we try to do the same thing again, when we try to save the same world, um, it will return false. So we have that, and if we test, we'll see that we are all good. And this one right here, the next one will test for the opposite. So it tests if we are able to add a world, to save a world in our database. So this method right here will actually add, will try to add a method, a world in our database. We'll be using these data to feed this method in order for it to return a value. And obviously, the result will be true because the database is is empty by the time it gets to the sys. So if we run that, we'll see that we're all good with the sys. Perfect. Now for the obstacle, which does the same thing, we have our data that we're going to feed our methods so that it can give us data. So when we start, obviously the database is empty, and we're going to feed our our method, our add obstacle methods, this data, and then it's going to return true because there's nothing. It also does the same thing. It checks for an obstacle inside of the database. If it isn't, if there is no obstacle that we try to save, then it will be true. Otherwise, it will be right. This we had to like add the same world, the same obstacle twice, and as you can see, the results will be different. And if we run our test, we'll see that would be good. Perfect. And the next one will be, we also had like a test to get the data from uh, from our database. So what this does is it gets data in JSON format, and let me walk you through this whole implementation. So we have this, and initially, obviously, when we try to get the walls, all the data, it will be empty because, like I said before, when we run each and every single test, the database will be cleared out. So when we get the walls from the database, the response will be empty because this object right here will be empty. But when we add um, world, a world to our database, and we feed this add world method this data, then the results will be different. The response will be different. We're doing the same thing. We're getting the worlds, and we holding the data, the response inside of this variable, and then we check for if the response is empty or not. And if we run our test, you'll see that we are all good. So this is how we were able to test some features in our database class for our database. And yes, this is it.